Hello, everyone. Welcome back. Today, we're going to talk about solving rational equations. So, starting with this one here, and we'll also work on this one here as well. Okay, so for this first one, the first thing I'm going to do is I'm actually going to state the restrictions. I'm going to state right off the bat that x cannot equal to -1 and x cannot equal to 4. And so if in our final solution we get that x does equal -1 or x equals 4, then we can actually disregard it and say that there is no solution, because in this original equation, we know that the equation would be undefined with either of these values, right? And so therefore, there would be no solution in the case that the solution we find is one of the restrictions. Okay, now I'm going to cross multiply. So I'm going to put 2x plus 3 times x plus 1 on the left and 5 times x minus 4 on the right, like that. Then I'm going to multiply through. So we're going to get 2x squared plus 2x plus 3x plus 3. And over here, we're going to get 5x minus 20. Now I'm going to get everything on the same side. So over here, we're going to have 2x squared plus 5x minus 5x, because I'm subtracting from the other side there. And then plus 3 plus 20 is equal to 0. That means that 2x squared plus 23 is equal to 0. And that means that x squared is equal to negative 23 over 2. And that's not possible, right? There's no possible answer for this other than an answer that would involve I. Okay, so x is equal to the square root of negative 23 over 2, which is equal to the square root of -1 times the square root of 23 over 2. So the answer is the square root of 23 over 2 times I would be our final answer for that one there. All right, let's move on to the next one. All right, so for the second question, the first thing I want to do is I need to combine the fractions that we have here. So in order to combine the fractions on our left side, what I need to do is get the denominators to be equal. To do that, I'm going to multiply the first fraction, numerator and denominator, by x plus 2. And then I'm going to multiply numerator and denominator of the second fraction by x minus 2, like that. Then I'm going to use the distributive property to simplify this a bit further. So we're going to get 4x plus 8 over x minus 2, x plus 2, plus 3x minus 6 over x minus 2 times x plus 2. And this is equal to 7x over x squared minus 4. Okay, next I'm going to combine the fractions into one fraction. So if we do that, we get 7x plus 2 over, well, x minus 2 times x plus 2, which if we do expand that, we get x squared minus 4, as this is a difference of squares, is equal to 7x over x squared minus 4. Then I'm going to cancel these denominators. So therefore, we just have 7x plus 2 is equal to 7x. And then if we subtract 7x from both sides, we get 2 is equal to 0. Now, would 2 be equal to 0? Well, this is never true, right? It is never true that 2 is equal to 0. And so therefore, there are no solutions. And not even like the last time where there's no real solutions, but we can get a complex solution via the square root. Here, there really is no way to have 2 equal to 0 there. And so therefore, there's no solutions for this one.